Exercise 14.7. Write each of the following expressions in the form x plus p whole squared plus q. That means we need to complete the square of the terms given in this expression, and then there would be some residual term or a constant term like represented by q in this form. So we need to do it like this. For that, we need to memorize these two identities. A plus b whole squared, that will be equal to a squared plus 2ab plus b squared. And if there is a negative sign in between, so only 2ab term would become negative. Rest of the two terms would be the same. So what I mean to say is the second identity to memorize is a minus b whole square is equal to a square minus 2ab plus 2 plus b square. Okay, let's apply this identity onto part A. Question 1, part A. X squared plus 6x plus 14. You can understand this completing the square method in two ways. If you concentrate to these identities, actually, you need to see that as a square means square of something, here we are having x squared. X square is square of x. Then there is a term 2ab. So 2 is this of the formula times a. A stands for the first term. In this case, the first term is x. So I need to have multiplied it with x so that it becomes 2x. Now, we are done with 2a. Now, we need to think what should be this second term b so that when it gets multiplied with 2x, it should give us 6x. Obviously, that is 3. That tells you that b should be 3. So then we have got b square. So that's why we should be having 3 square, because in this case b is 3, a is x, and 2 is the same. So that's why we write down like this. Okay, to complete this thing. But in the given question, we were just having positive 14. Since we have added this 3 square at our own, we need to balance it out by subtracting its square as well. So we have added and subtracted square of 3. And then finally this 14 would be there in this question. And this contains a positive sign, so that's why the sign is going to be positive. So now if we combine x square plus 2 times x times 3 plus 3 square. If we combine these three terms, according to this identity, these are equal to square of a plus b. So this will give me square of a plus b. A in this case is x. So this is x plus b in this case is 3. X plus 3 whole square. And finally, this negative 3 square plus 14 is left, which is negative 9 plus 14. Simplifying it, we get x plus 3 whole squared plus 5. So if you compare this with the given format, we are done with the completion of the square in this term, and a constant term should be there. And the constant term in this case is 5. So we can also say that P is 3 and Q is 5. So that completes part A. Okay, in the same pattern, we need to solve part B. Let me explain it in a different way. Part B is x squared plus 8x plus 1. There are two methods to understand it, as we were doing in part A. So let me do it first of all with the same method. Square of x, then to have a plus b whole squared, a square plus 2ab plus b squared. I've done x square, which is the first term of this identity. Now I need to make the second term to look like 2ab. So that's why I'm going to do it 2 times the first term, that is x. Now I need to think, what should I multiply this with so that I can get 8? So obviously that number is 4. So we are done with 2ab term. And then finally this is b square. So b square would be the same, because in this case I have figured out b to be 4. So I need to have this b squared. That means I need to have 4 square. As I have added it at my own, so I need to balance it out. So I need to subtract its square as well. And finally this one would be there. So this is what we have added and subtracted at our own requirement to complete the square. From this, now these three terms would complete the square as in the case of this identity. So that will give us a plus b whole squared. In this case, a is this x and b is this 4. So we can write it down x plus 4 whole squared. And finally, we are left with these two terms, which are negative 16 plus 1, which is negative 15. So that completes the question. We have converted it in the required form, showing that the value of P is 4 and the value of Q is negative 15. Okay, that was one of the methods to understand it. There is another method to think it on the other way around. That method is if this is x squared plus 8x plus 1. You need to see that is the standard procedure, that whatever is the coefficient of x, in this case is 8, you divide it by 2 or you half it, and then you take its square, whatever you get. In this case, we get square of 4. So you need to add and subtract this into this expression to complete the square. So what I mean to say, you just do it. The first two terms are copied down as they are, no change in them. Then plus 4 square minus 4 square, and then finally plus 1 would be there. That will give you x plus 4 whole squared minus 16 plus 1 minus 15. That is your answer. And if you just see it, that will give you that P is equal to 4 and Q is equal to negative 15. So again, in both the ways, you get the same answer, but the actual difference is the method of thinking it, whether you find this method easy, or you find this way to think more easy, that's up to you. This is the standard procedure that we have applied. The standard procedure is you divide the coefficient of x by 2 and you then take square of it, and this is the term or the number that is added as well as subtracted. That's what we have done in this case. We have added 4 square and we have subtracted 4 square. Now let me solve its part f, for example. Uh, x squared minus 2x plus 17. The square of x is there, then there is a negative sign, so the second identity is going to be used. That means negative 2 times the first term is a, that is x, that is this. Now what should be the second term? What should be the second term so that we get 2x once again? So obviously that should be 1. So when you multiply these three terms together, you get negative 2x. So we need to add 1 square and we need to balance it out, subtract 1 square, and finally at the end we need to have this 17 written here. So now these three terms complete the square, a plus b whole squared. Substitute their values like x plus 1 whole squared. And these two would be solved together. Negative 1 plus 17, which is plus 16. So comparing it with this, we say that P is 1 and Q is 16. And if we do it or solve it or think it the other way around, so that would be x square as it is, negative 2x as it is. So now the coefficient of x, we need to divide it by 2 and then square it. In this case, the coefficient of x is 2, this one. So we need to divide it by 2 and then square it. 2 gets cancelled out. This is 1 square. So this is 1 square that you need to add or subtract. So that's what we did previously. So in both the ways, you can understand it. Okay. Now I do its last part L. This is because it has got its coefficient of x to be even. So that would make these parts of the same type. So that's why I've chosen part L first. So that is x squared minus 20x plus 400 square of x. Then let me solve it using this technique. Coefficient of x, half it, and then take its square. In this case, the coefficient of x is 20 divided by 2 and its whole square. That will give us 10 square. So I need to add and subtract 10 square. So First two terms are the same. Just we need to add 10 square and then subtract 10 square. Then the last constant number is coming there without any change. Now, these three terms would complete the square, x minus 10 whole square. Now, this is the second term b, this is the first term a. So that's why I've done a, b, and with there, in between them, there is a negative sign because 2ab term is in the negative sense. That's why. So, x minus 10 whole square and simplifying them together, negative 100 plus 400, which will obviously give us 300. So that completes the question, giving us p is equal to negative 10 if you compare this with this given format, and q is equal to 300. Okay, with this, now you see, observe that the parts G till K, all of them have got odd coefficients of x. So this would be done exactly on the same pattern, but in this case, the term that would be added or subtracted, that would be occurring in the form of a fraction. So let's start solving them. Part G, for example, x square plus 5x plus 1. The first term is as it is, the second term is there without any change, and then now I need to apply coefficient of x divided by 2 and its whole square. In this case, the coefficient of x is 5. So 5 by 2, its whole square. This is what is to be added and subtracted. So I need to add 5 by 2 whole square, and I need to balance it out by subtracting the same term, and then finally this one would be there like this. Now you see, this is the second term b, and this is the first term a. So the square would be a plus b whole squared, combining these three terms, which will obviously give us x plus 5 by 2 whole squared. And then these would be solved or simplified together. That will give us negative 25 divided by 4 plus 1. We can simplify like plus, making the denominator same, so that the denominator is 4, and over there I am writing down this term first and then this one. So finally we are having x plus 5 by 2 whole squared minus 21 by 4. That completes the question, solving and giving that p is equal to 5 by 2 and q is equal to negative 21 by 4. Let me do its next part. Let it be part I, for example, x squared minus 3x minus 3. X square is the same, the second term is the same, no change in that. So again, the coefficient of x divided by 2 and its whole square. In this case, the coefficient of x is 3. So 3 by 2 whole squared. That's what I need to add and subtract. 3 by 2 whole squared added as well as subtracted. Then finally this negative 3 would be there. Now these three terms would complete the square, giving your this second term as b and this as a. So we can have a minus b whole square because this 2ab term is negative in this case. So that will give us x minus 3 by 2 whole squared, and simplifying them together, negative 9 by 4 minus 3. Making their denominators same, you get negative 9 and negative 12, which is negative 21 by 4. And that completes this question, giving p is equal to negative 3 by 2 and q is equal to negative 21 by 4.